Well, this is a video to demonstrate the report and the video proficiently illustrated different objectives from 1 to 10. So I will go over one by one by following my report. It's under the project description part. The first one is the design principles. The design principles of the software engineering include many things such as the principles of least privilege, and which can be applied to every level of a system, including end users, system, processes, network, and so on. But for the Minesweeper game, for example, no matter of choosing different level or click on menu buttons or the process of each game or each play, the subject of processing the game should only be given the privilege to open it and implement it inside the application. Like the right hand side, when I just click different buttons like game, top 10, yeah, it should only implement inside this application or help. It shows the different help tips, and even though I click the restart button, it should still stay here. And the next one is the fail-safe defaults relates to the system only. Give the users right to access the source file when the user gives the permission, get the permission from the system. Apparently in this Minesweeper game, no one or no user need to step into the source file to change anything behind the game application. And the separation of concerns relates to the number of grants of the system at the same time. The operation system should only give the permission to a single condition, which in the Minesweeper game means the game can only be played by one player at the same time. If other players would like to try, they should wait for the existing player end his or her process. Like this game can only just open one panel or one user interfaces. If other players would like to play, he or she need to download all the packages to their own computer to run it on their own computer. And during the design of the application, the information hiding now will be applied into the encapsulation principles. The encapsulation because the encapsulation principles when I just write all the codes here, comparing write everything into one single file. Let me show you my first version of Minesweeper here. Source package, sweepers, and the Java Minesweeper app. I write everything into one file, so it has lots of different functions just inside one class. So if other people or application or software would like to use one or more extents or models inside this one, it's hard to retrieve all the data to there. So let's go to the model by using here. By following the encapsulation, I named different classes that each file can inheritance or use in directly. And now the coupling relates to the degree to which components depend on each other. Also, the low components, the high cohesion and encapsulation will be described later in more detail. The objective 2 is the design process. The design process of the software development is critical for both developers and users. It could illustrate the achievable requirements. For the Minesweeper game case, for example, it has been transformed into the model wheel controller pattern, depending on different functions that each file will represent. Just like I represented you, like the score model will just run the function of keep the scores of each player, and the button controller will just handle all and all the buttons function belongs to each button. So the game has been detailed into different forms as above screen capture. Yeah, I also give a screen capture here. The broad wheel, the Java takes the GUI part, menu controller takes the menu data, and the button controller takes the responsibility of event and the listener function. And also this design used the event-driven pattern. Later I will talk about that. Minesweeper model Java shows the main bomb's relationship with the empty grids. It's just the zero is there means the empty grids. For architecture design, it should manage each sub-elements of system interact with each other. Developers will make choice by using structure design to meet to accomplish all the functional requirements. Developers should design the structure in an effective way and able to accept changes of architecture designs. The next one, objective 3 is the system modeling. For designing the system modeling, I consider the functional requirements by using the Pareto's 80-20 rules because most of the players or users only use the 20% of the features of each of the application or software. The main function of the main sweeper is the algorithm of calculate the number of bombs surrounding a specific grid. Like the right hand side, there is a 2, and 3 means there are 3 at least. No, there are total 3 bombs around this specific grid. And for the functional requirements of the Minesweeper game, at the final stage, there are 2 models have been created: the Minesweeper model and the score model. The Minesweeper model provides the bomb number, bomb position, and the proper value that should be displayed when a grid is revealed. And here's the function. And the score model provides a function of add score, save the score for each players, and the players do not need to know exactly the class of the object. They can just only use it from the protocol. So it applies the encapsulation protection principle from the software designing principles. Now, the objective 4 is the design paradigm. The design paradigm of the software development should focus on the function-oriented design, object-oriented design, data-centric design, and case study. For example, the Swiss Army knife is a design paradigm that shows the concept of a single object that alternative configuration to be addressed for a lot of problems. In this case of the Minesweeper game, the model wheel controller can just provide a paradigm for simple computer games that need the timer and the score functions. It has separated score model and timer function fields that can be example of the model wheel controller. And now the objective 5 is the software architecture. For this application of Minesweeper, I chose the model wheel control architecture. It will be more suitable software architecture in this game. It can reflect the functional requirements 1.12 as the milestone 1. I have presented to the assignment and the technical reacting. Yes, the technical reacting is the part of calculate the different grids numbers surrounding bombs. And the technical reacting requirements needs the game application to be able to give response for players' action on the game user interface, including each mouse click, button click. For example, when the user should be able to click on the button of start button, and then the system should respond to the user interface with a brand new grid interface, no matter the existing game over or not. By doing above requirements, the MVC pattern provides the controller to handle the user click as an input and commanding the model to notified. Then the model